makeuseof.com, and today we have an Arduino Programming for Beginners video. This is the traffic light controller project tutorial. We have an article for this on the main Make Use Of website, but today we're going to cover all three sub-projects that are in this article in the video. But before we go any further, there is a little bit of hardware that you're going to need ready before we get started. If you got a starter kit with your Arduino like the one that I have here, then you already have all the bits that you need. If you didn't, you can get all of these parts for very cheap online or at any good hobby electronics store. We're using an Uno clone today, but you can use any Arduino for this project, and we need one 10 kilo ohm resistor, 6 220 ohm resistors, one push button, and of course our traffic lights, namely 2 red LEDs, 2 yellow LEDs, and 2 green LEDs. You're also going to need a breadboard and some hookup wires, along with a USB cable to attach the Arduino to your computer. Let's start by setting up a basic Arduino traffic light circuit. So you'll need to set up your red, yellow, and green LEDs on your breadboard, and they are going to pins 10, 9, and 8 of the Arduino respectively. However, between the pins and the long legs of the LEDs, you want to put a 220 ohm resistor each. Also, you want to attach the 5 volt and ground pins of your Arduino to the live and ground rails on your breadboard. If this seems a little confusing from the video, head to the Make Use Of website where there is a fritzing diagram of this. There'll be a link in the description to the article in question. To program your Arduino, you're going to need to use the Arduino IDE. If you don't already have it installed in your computer, head to the Arduino website, which is arduino.cc, and download the Arduino IDE and install it for your computer. Today we are using Windows, however you can get it for Mac OS X and Linux, but you might have to connect to your board slightly differently to the way that I do it today. Open up the Arduino IDE and create a new sketch. We will start by telling the IDE which pins we want to use for our LEDs. So we're going to create 3 integers called red, yellow, and green and give them the correct pin numbers, 10, 9, and 8. Now we're going to use our setup function to set up these pins as outputs. To do this, you need to use the pin mode method, and you need to enter the name of the pin followed by output, all in capital letters. This means that when the Arduino starts up, it'll know to turn this pin, which we've already said is pin number 10, into an output. Next, in our loop method, we're going to call a different method called change lights. Now this doesn't exist yet, we're about to make it down here. And then once we've called this method, we want the program to wait for 15 seconds. So we ask for it to delay for 15,000, which will give you a 15-second delay. Now we create the change lights function. Now I've already got it pasted in here, and I'm not going to go through every single part of it because it does the same thing over and over. Also, if you want this code, as I've mentioned, you can get it from the article on the Make Use Of website. That will be linked in the video description. But once change lights is called from the loop function, it comes into here, and as it says here, it starts by turning the green light off and the yellow on for 3 seconds. Now this means that digital write, this is writing to our digital pins. We're writing to the pin that is green, i.e. pin number 8. And we're telling this pin we want it to be low. This will turn the LED off. Also at the same time we want this digital pin to be high, and this is the yellow pin, so it'll turn the yellow pin on and it'll stay like this for 3 seconds. Now that you know how low and high and delay work, you'll be able to see what the rest of this function does quite easily. The yellow goes off and the red comes on, there's a delay of 5 seconds, then just the yellow comes on with a delay of 2 seconds, and then the yellow goes off, the red goes off, and the green comes on for a delay of 3 seconds. Now, if you haven't already, plug your Arduino into your computer via the USB port. You're going to need to make sure that it's set up correctly with the Arduino IDE, and the way you do this is by heading up to the Tools menu here, and looking down under where it says Board. Now I am using an Arduino Uno clone today, so that is what I have selected. However, no matter what kind of Arduino that you have, you will find it in this list. And if it isn't in this list, head to the Boards Manager and search for it. You'll probably find there is already a version of it in the Arduino IDE. You're also going to want to make sure you're using the correct communication port. Now I know that in COM10 I have my Arduino because it actually shows up here. If you have several COM ports and you are not sure exactly where it is and which one, if you open up the Device Manager on Windows and look under the USB ports, you will see there'll be various ones here. Now, even if it isn't clear, even if one of them doesn't say Arduino, by process of elimination, you should be able to work out which one is your Arduino. Once you've got your board set up, you will need to save your sketch. You can do that from here by clicking the Save button, or you can go into File and click Save or Save As to give it a different name. Next, you will need to compile and upload your code. So you can just click the tick, and this will verify that your code compiles correctly without uploading it to your Arduino board. We want it to compile and upload, so we'll click Upload, which will compile it first and then upload it to the board. This can take a few seconds, but once it's uploaded, it will start running straight away. Now that the code's uploaded, you should see your traffic light work, i.e. it begins on green, and then after a pause it will change to red, and then go back to green again. And since we set up that delay in our loop function, it will do this every 15 seconds forever, as long as it is plugged in. If it didn't work for you, make sure that you had the right communication board and board type set up in the Arduino IDE. Now let's move on to something a little bit more complicated. Now let's add a simple button to the project, the idea being that when the user presses the button, the traffic lights will change. The fritzing diagram in the article on the Make Use Of website will show you how to set this up, but very briefly, one side of the button has the power and then it goes to ground through a 10k resistor, and the other side of the button has the line which runs to our Arduino. It's set up this way so that the Arduino gets a clear signal of when the button is pressed. Now that we've set up the button in the circuit, let's set it up in our code. So create a new copy of the sketch that you just had. I just had exactly the same sketch, but I have saved it as TL2 instead. And what we're going to do is add a new integer here at the top for our button. So here we say integer button equals 12, which is where we plugged it into our Arduino. Now we need to add a couple of lines to our setup function. So here, just like we set these pins to be outputs for the LEDs, we need to set our button pin mode to be an input. We also want to set the green LED to be high at the start so that when the traffic lights are not in operation, they're just green. We only want them to turn to red when the user presses the button. Now we need to make a change to our loop, because we don't want this to just change all the time. We only want it to happen when the button is pressed. To do this, we're going to use an if statement. So if, and then we open brackets, we want to do a digital read. This is the same as digital writing, but for the input. And we want the digital read to be the button, and we want to know if it is high. We encase this in curly brackets, so we put 1 here, and we put 1 underneath here. So what this means, in theory, is that every time the button is pressed, it goes high, and it will do whatever is in here. But we're not quite done. So in theory this should work, but what we're actually going to do is create yet another if statement here, which looks almost exactly the same. So digital read, and it says button, and equals high, and we have an open curly brace just like before, and underneath this bottom if statement we want another one, the idea being that this if statement is inside this one, but before the second if statement goes, we're going to put in a very small delay. Now this delay is known as a software debounce. You don't have to understand how it works. The main reason we're doing this is just so that we don't get any strange readings from the button when the user presses it. Sometimes the way that Arduinos work require just a little bit of extra work in the code to make sure that what happens when you do something is exactly what you want to happen. Now that we've made this change to the loop function, we don't actually need to change the change lights function. That's because this still does exactly the same thing, it just only does it when the user presses the button. Now as you can see down here I have an exit status, and that's because I've already compiled this code once and there was an error, so let's quickly do that again. Compiling code will show you where the errors are that you make, and I have made a very simple error here that some of you may have already noticed while I was typing. It says it expects a closed bracket, and that's because I opened a bracket here to say if the digital read, and then opened the bracket for the button, closed that bracket, and then said equals high, and never closed this bracket. So the compiler didn't know what to do, but now if I save it and compile it, everything should work perfectly well, and provided it does, I will upload it to my board. Now that this code is uploaded to my board, I can press the button and the lights will change. So that's pretty good. We've added a little bit of user functionality to our project. But let's do something different again and set this up as if it was a junction with two sets of traffic lights.